Welcome to the last video of the section, Organising Clusters as a Hierarchical Tree. As we already know, an alternative to k-means is hierarchical clustering. One advantage of hierarchical clustering is that it allows us to organise the different clusters in hierarchy. It's also known as a dendrogram, which can make it easier to interpret the results. Another useful advantage is that we do not need to specify the number of clusters up front. Let's look at two approaches of hierarchical clustering. In agglomerative hierarchical clustering, we start with each data point potentially being its own cluster, and we subsequently merge the closest pair of clusters until only one cluster remains. In divisive hierarchical clustering, it's the other way round. We start by assigning all the data points to one and the same cluster, and we subsequently split the cluster into smaller clusters until each cluster contains only one sample. Let's dig deeper into implementing the agglomerative hierarchical clustering. Although OpenCV does not provide an implementation of agglomerative hierarchical clustering, it's a popular algorithm that should, by all means, belong to our machine learning repertoire. So we'll start by importing make_blobs module from sklearn datasets. Then we'll execute this line of code to generate 10 random data points, specifying random state as 100. Using the familiar statistical modeling API, we'll import the agglomerative clustering algorithm from sklearn and specify the desired number of clusters with this code. After that, we'll fit the model to the data, works as usual via the fitPredict method. Finally, we'll add and execute this block of code. Here in this part of the code, we import the py plot as plt, and also specify the styling of the plot. With this line of code, we generate a scatter plot where every data point is coloured according to the predicted label. So the generated plot is the clustering result of agglomerative hierarchical clustering. That's it. This marks the end of another wonderful adventure. The next section is about using deep learning to classify handwritten digits.